In this example, we're given a polynomial, and it says f of 7 is equal to 0, so if you plug in 7 for x, you get 0, and we're asked to find all factors. So a couple things to look at the very bottom here, the difference between factors and roots. So I have a polynomial, x squared plus 8x plus 15, that's called expanded form. If you factor it, that means parenthesis form. The factors would be x plus 5 and x plus 3. If you want to find the roots where it crosses the x-axis over here, then you would have to set these factors equal to 0, or the quicker way to do that is to just flip the sign. So this becomes a minus 5 and a negative 3. So this is where it would cross the x-axis at negative 5 and negative 3. And if I plug in negative 5, you should get 0, right? If you write that as an ordered pair, negative 5 comma 0 is an x-intercept, and negative 3 comma 0 is an x-intercept. So if I plug in negative 5, I get 0, and if I plug in negative 3, I get 0. So knowing those facts, let's take a look. They tell me that 7 is a root. So when I plug in 7, I get 0. So if I want to turn that into a factor, remember factors are parenthesis form. Let's take a look at our example below. If I want to turn this into a factor, all I have to do is flip the sign, right? So the factor would be, for this one, x minus 7, because 7 comma 0 was the ordered pair, so you flip the sign to a negative 7. So if I want to find the other factors, I can use synthetic division and divide this. So for synthetic division, I'm setting up this opposite sign here, which is positive 7. And then I look at all the coefficients, which are 1, negative 8, 1, and 42. And I also noticed that no exponents were skipped, so I don't have to put any zeros anywhere. So I bring down this first number, which is a 1, and I multiply the 1 times the 7, so that gives me an answer of 7, and then I add these together. Negative 8 plus 7 is negative 1. So from here, I multiply these together. 7 times negative 1 is negative 7, and then I add these together. 1 plus a negative 7 is negative 6. Now I multiply these together. 7 times negative 6 is negative 42, and then I add these. 42 plus a negative 42 is 0, and that's what I was expecting because my remainder should be 0 if it is a root. So from here, I need to add my variables, so I know to decrease the power instead of to the third, it's to the second. So it's 1x squared minus x, and then minus 6. So right now, my factors are the following. So the first factor I got was x minus 7, and again I got that from taking this and flipping the sign to the opposite and turning that into a factor. And then my second factor comes from here, which is x squared minus 1x minus 6. However, I can still factor this further. This is a trinomial in the form of x squared, x, and a constant. So I can say what multiplies to the back number negative 6 and adds to the middle number negative 1. There has to be one negative to get a product that is negative. So the factor pair that would work here would be negative 3 and positive 2. Because negative 3 times 2 is negative 6, and negative 3 plus 2 is negative 1. So I'm going to rewrite my factors here. X squared splits as x, and I'm using my two new factors, which are negative 3 and positive 2. So the factored form here for this original polynomial would be f of x equals x minus 7, x minus 3, and x plus 2. And again, there's no particular order. You're multiplying these together, so it doesn't matter what order you write the factors in. If you had to find the roots, which you don't have to here, but if you had to find the roots, you would just flip the sign. So it crosses the x-axis at 7, at 3, and at negative 2.